Hi, this is Unit 4 Bonding, and in today's lesson we are going to learn how to name ionic compounds, and then, given the name, how can we write the chemical formula. So the rules for naming ionic compounds comes from the International Union of Pure and Applied Chemistry, which is what IUPAC stands for, but it's really just a universal way for naming compounds. So when you see a test question or a quiz question, it'll say, according to IUPAC. All that is the way I taught you how to name the compounds or how to write the compounds. So compounds have a common name and they also have a chemical name. There's a systematic method for naming ionic compounds, and we're going to concentrate on the chemical name. We always name the positive element first because it's always written first. And we name the negative element second. Replace the ending of the negative element with IDE. So if fluorine is the second element, it would change to fluoride. If oxygen was the second element, it would change to oxide. So let's do some examples. We simply name the first element. The first element is sodium. The second element is chlorine, and we change that to chloride. Here the first element is potassium. We simply name it. And we change the second element, oxygen, to oxide. Notice how they both end in IDE. Calcium, and then the second, bromide, because bromine changes from bromine to bromide. Next one, aluminum, and sulfur turns into sulfide. And in the last one we have lithium, and iodine changes into iodide. Not so bad, right? Okay, now let's go from the chemical name to the formula. We were doing this the other day. In order to do this, you need to have the chemical symbols. You need to have their oxidation states, which you get from the periodic table, +1, -1. And then remember, you drop and cross. But because this is a 1-to-1 ratio, we don't have to write the ones, so it's simply LIBR. Sodium is Na, fluorine is F, and it's a +1, -1, so when we drop and cross it's still 1-to-1, so it's NaF. And the next one, magnesium, is Mg, and Cl for chlorine. Mg's got a +2 charge, Cl has a -1. So when we drop and cross here, the 2 comes down by the chlorine. We don't write the 1, so it's just MgCl2. Remember, bend and snap, drop and cross. Potassium is K, iodine is I, +1, -1, so this is a 1-to-1. We don't have to do anything, and it's simply Ki. For polyatomic ions, they're named exactly as they are seen on the table, in Table E. So what you're going to do is if an element is present, you're going to name the element and simply name the polyatomic. If the polyatomic is first, you name the polyatomic. If the element is second, you change the element to IDE. If it's 2 polyatomics, you just simply name them. So let's do a couple of examples. Here we have sodium, so we're just going to name that. And if I go to Table E, I see that the OH is the hydroxide ion. K is potassium. And if I go to table E, I see that NO3 is nitrate. All I'm doing is writing it down exactly as it appears. Ammonium. So now we're going the other way. Ammonium is a polyatomic. Well, how do you know if a word is, that when you're given a chemical name, if it's found on the periodic table or table E? Well, if you can't find it in the list of elements in table S, then you know it has to be a polyatomic. So ammonium is NH4, and it has a +1 charge. And hydroxide is OH minus, and it's a -1 charge. So no dropping and crossing here because they are 1 to 1. So the formula is simply NH4OH. Calcium phosphate. Calcium has a +2 charge. Phosphate is a polyatomic. It's PO4 minus 3. So now this 3 has to come here, and this 2 has to come here. So it becomes Ca3. Well, I can't write PO4 and then a 3 next to it. What this is telling me is that I have 3 PO4 groups. So I have to put the PO4 in parentheses and then put the 3. So when you have a polyatomic and you drop and cross, if the subscript is not a 1, you must put the polyatomic in parentheses. For example, if I have magnesium nitrate, magnesium is +2, nitrate's -1. So when I drop and cross, this is going to be MgNO3 2. Now, if I have something like sodium Na sulfate, sodium's +1, sulfate's -2, this 2 comes down here. So I don't have to put a parenthesis here because it's going to be Na2 and there's only one SO4. So hopefully that helps. All right, let's talk about transition metals. Transition metals tend to have more than one oxidation number, so you must use a Roman numeral to indicate the oxidation number within the compound. The Roman numeral appears in parentheses after the element symbol. Well, if you don't know your Roman numerals, that's going to be a problem. So 1 is simply 1, 2 is 2, 3 is 3, 4 is IV, 5 is 6, 7, 8, 9, and 10. These are not on the reference tables. All I've really ever seen them use is the first 4. I have seen them use a 7, but I just wanted to make sure that you were aware of them. So for example, when we look at cobalt, cobalt's got a +2 and a +3. So I'll come over. So we have to look at which one do we want to use. We could wind up with COCl2 or COCl3 depending on the oxidation number that was used for cobalt. Remember, I told you the other day that when you drop and cross, you also can go up and over. So this 2 came from up here, and the positive is always written first. There's an unspoken 1 here, that would be the negative. So you know that the Roman numeral 2 was used for cobalt. So this would be cobalt, Roman numeral 2, chloride. And this one, this 3, came from up here, and there's an unspoken 1. So this, we used the +3 oxidation state. So the Roman numeral actually stands for the number, okay? Plus 3 means Roman numeral 3. Plus 2 means Roman numeral 2. If it was a plus 4, I'd use the 1V or IV. So this one is cobalt Roman numeral 3 chloride. The only way to get good at these is to practice. So that's all we're going to focus on today. We are going to do some more examples. So let's go back. We have zinc oxide. This is what's considered a binary compound. I'm going to introduce that word, binary compound, and that means 2 elements only. So it's our normal rules. Zinc is plus 2, oxygen is minus 2, so it's just going to be ZnO, because 2 to 2 is the same as 1 to 1. Iron 2. They're telling me that the oxidation state of iron is plus 2. So this is plus 2, chlorine is minus 1, so when I drop and cross, I get FeCl2. Mercury 1, they want me to use the plus 1. Sulfur is minus 2, so now when I drop and cross, it's going to be Hg2s. Just so you know, a ternary compound is 3 plus elements. So these would be ones that include our polyatomics. For example, MgSO4. That's an example of a ternary compound. Okay, that's it for today. Have a good afternoon.